In this project, we learn how to use Trivy to scan the security vulnerabilities. We will scan both Docker images and the local file system. The main goal is to understand security risks such as CVE vulnerabilities, learn different severity levels, and know how to read and analyze vulnerability report. Security workflow. The security process is simple and practical. First, we build the application. Then we scan it for vulnerabilities. Next, we analyze the results. If issues are found, we fix them. Finally, we deploy a secure application. System flow explanation. The process starts with developer code, which can be source code or a Docker image. This code is built into an artifact such as a Docker image or file system. Next, we run a security scan using Trivy, which checks for vulnerability. The scan produces a report including CVE, severity levels, affected packages, fixed versions. Then we evaluate the risk. If it is critical, we must stop and fix it. If it is high, we should fix it soon. If it is low or medium, we can monitor it based on the result. If not safe, we fix and scan again. If safe, we deploy the application. This creates a continuous security loop. Demo flow. Now let's look at the demo process. First, we install Trivy. Then we go to the project folder and make the script executable. Next, we scan the Docker image. After that, we check the generated report file. Then we scan the local file system. Finally, we check the file system report. This shows how we can quickly scan and generate the security reports in real projects. Demo. Great result. Now let's focus on the more important part of this project, how to read the scan result. Here is an example output. At first, we look at a bit technical, but it is actually very simple once we break it down. First, we have the CVE ID. CVE stands for Common Vulnerability and Exposure. It is a unique identifier for a no security issue. You can think of it like a bird ID for security problems. Next is the severity level, such as low, medium, high, or critical. This tells us how dangerous the vulnerability is. Low, not very serious. Medium, moderate. High, dangerous. Critical, very dangerous and urgent. Then there is also a description which explains what the issue is about. The key takeaway here is If you see critical, you must fix it immediately. If you see high, it is also very risky and should be fixed soon. So reading this output helps you quickly understand what is wrong, how serious it is, how to fix it. Export report. Now let's move to the next step, exporting the scan report. We can use this command. This command tells Trivy to scan the image and save the result as a JSON file. Why is this important? Because JSON is a machine readable. It means all the system can easily process this data. For example, after reading this command, we can open the file image report JSON. Inside, we will see structured data, list of vulnerabilities, severity levels, affected components, fixed version. This is very useful in real-world scanner. First, inside CD pipeline, we can automatically scan every view. If a critical issue is found, the pipeline can fail. Second, in security dashboard, we can visualize vulnerability across systems. Third, for automation, we can write scripts to analyze or filter results. So instead of manually checking results, we can automate everything. What just happened? At this point, you may wonder, what exactly did Trivy just do? Let's look at it from a high-level perspective. When we run a scan, Trivy checks multiple things. OS packages like system-level software, library, used by applications, dependencies, internal components your app relies on. Trivy compares the components against a vulnerability database. Then it generates an output that includes a list of vulnerabilities, their severity levels, and the fixed version. In simple terms, Trivy is acting like a security scanner that tests your software for no problems. It does not guess. It uses real, no vulnerability data. That is why it is fast and reliable. Project structure. Now let's take a look at the project structure. This structure is simple but very practical. We have three main scripts: scan, run the full scan, scan image, scan Docker image, scan app, scan the file system. And we also have a report folder where all results are stored. The idea here is automation. Instead of typing long commands every time, we just run a script. This makes the process faster, more consistent, easier to review. This is how DevOps engineers typically work. How it works? Let's simplify everything into a clear flow. Here is how it works step by step. First, we provide an input such as a Docker image or source code. Second, Trivy process a scan. Third, it detects vulnerabilities using CVE database. Finally, it produces a report. This is a simple but powerful pipeline. If possible, this is a great place to show a diagram because visual flow helps people understand faster. What's it master? Now let's talk about why this is important. The problem is simple. If we deploy an application with vulnerability, it can be exploited by attacker. This can lead to data leak, system compromise, business limit. So what is the solution? We scan before deployment. This allows us to detect and fix issues early. The key message here is security should be part of CI/CD, not something we do later, but something we integrate into the process. Real DevOps workflow. Finally, let's connect everything to a real DevOps workflow. Here is how it works in practice. First, developer build a Docker image. Then the system automatically runs a Trivy scan. If a critical vulnerability is found, the pipeline stops immediately. Developer must fix the issue and rebuild the image. Only when everything is safe, the application is deployed. This ensures that only secure applications go to production.